So let's look at how these problems work out mathematically. Problem 1 here says that two train cars are on the same track and car 1 is moving 3 meters per second to the right and car 2 is not moving at all. If the cars connect when car 1 collides with car 2, what is the total momentum and the speed of the cars after the collision? Car 1 has a mass of 10,000 kilograms and car 2 has a mass of 5,000 kilograms. You got 5,000 kilograms on car 2, 10,000 kilograms on car 1, and it's moving at 3 meters per second. So when they want to know what the total momentum is, remember that momentum is always conserved, so it's just the momentum before the collision is the same as the momentum after the collision. So in this case, this car is not moving at all, so it has a momentum of 0. And this car is moving 3 meters per second at 10,000 kilograms, so its momentum is 30,000 kilogram meters per second. And that equals 30,000 kilogram meters per second. You just add them up. So the second part of this question, so that's the momentum of both cars connected. But the second part of this question is, what is the speed after the collision? So we can just use the momentum formula again, which was momentum, which remember from an earlier thing I said momentum was abbreviated with a P, is mass times velocity. Now we already know what the momentum is. It's 30,000 kilogram meters per second. And that equals the mass. Now it's the mass of both cars because now they're connected together. They're coupled together. So they're 10,000 and 5,000 kilograms. That's 15,000 kilograms times whatever the speed is. And actually it's the velocity. They want to know the speed and the direction. In this example, it's pretty easy. The direction is going to be in the direction of the moving car because this car wasn't moving at all. So what times 15,000 will give you 30,000? Well, if you divide both sides by 15,000, you end up with 2. Now what happens is when you have 30,000 kilogram meters per second divided by 15,000 kilograms, the kilograms will cancel out and you're left with just meters per second. So the answer is velocity is 2 meters per second and it's to the right. So that car is going 3 meters per second, hits that car, they get connected, and because the mass is increased, with the same momentum, the speed had to decrease. I hope that makes sense for you. Okay, let's look at another problem like this, but this time there's a little wrinkle here. Problem 2 says two train cars are on the same track. Car 1 is moving 2 meters per second to the right. Car 2 is moving 1 meter per second to the left. If the cars connect when car 1 collides with car 2, what is the total momentum and the speed of the cars after the collision? Car 1, again, has a mass of 10,000 kilograms, and car 2 has a mass of 5,000 kilograms. So we're going to do the same thing we did in the last problem. We're going to add the momentums together, except that this one is in the opposite direction of this one. So if you think about this in terms of like a number line, this is a positive number because it's going to the right, but this is like a negative number because it is going to the left. So what we're going to have to do is we're actually going to have to subtract these momentums, one from the other one, to get the total momentum of the combined cars. So 2 meters per second times 10,000 kilograms, that's going to be 20,000 kilogram meters per second. And this one is 5,000 kilograms times 1 meter per second. That's going to be 5,000 kilogram meters per second. Right? Except this time, because that's in the opposite direction, we have to subtract them. So you end up with 15,000 kilogram meters per second is the total momentum on this side once you subtract that one from that one. 20,000 minus 5,000. So since momentum is conserved, that means the momentum of these two coupled cars is now 15,000 kilogram meters per second. Right? So that's the momentum of the couple cars. Now, how fast are they going? Again, use the momentum formula. P equals mv. And we know the momentum is 15,000 kilogram meters per second. And we know that that equals the velocity times the mass, which the mass of the combined cars is also 15,000, because you got 10,000 for that one and 5,000 for that one. Times V. So, I know this is going to be really hard for you. What times 15,000 equals 15,000? Correct. The answer is 1. And kilogram meter per second divided by kilogram gives you meter per second. Now, the greater velocity was to the right. So the final velocity will also be to the right. Hopefully that makes sense. If not, email one of the other teachers, not me. I already did my, no, I'm kidding. Email me, feel free. I would be happy, more than happy to help you out. Stay safe, everybody.